from, okay, so we've heard from two groups that were able to solve it. Anyone else, or anyone have like, I don't know, something like an interesting challenge, or maybe you got stuck, or something that was unclear at first, then you went, oh, okay, I got that.
Are we allowed to use an array, a temporary array, while we're solving it?
Ideally, you wouldn't, although it is true I didn't put that in the list of constraints. I guess the way I would put that, maybe the best way to put that is it's linear in time and space. As if it's not linear in space, then you've added more memory to do it, right? So that maybe I should add that next time. Linear in time and space.
Well, we didn't have
for the
two folks going.
For like the doubly linked list class, can we use the methods that's in there?
Yeah, totally. Just not anything with. I think you don't need to. Just not anything with.
Like remove from head and remove from tail. Will that be considered pointing a previous? Because it's like the method's already there.
I guess. Oh, good point. I guess you can do that, although you don't need to. Tell you what, I'm going to go ahead and go through the solution, although I would love to discuss this more with all of y'all, because then we have another challenge, and then we want to look at the Q solution, and then we have another thing to do. So I do have to keep moving as much as I would like to discuss this more.
Can I find out if our solution was the right approach before you show us?
Yeah, cool. Let's do that.
So here's what I thought. As soon as Arpita said 2 pointers, I thought you get 2 pointers going. One goes down one at a time, and the other goes 2. It skips 2. And by the time the one that's skipping 2 gets to the end, the one pointer is at the middle.
Boom. That's it in a nutshell.
Is it really?
Yeah, that's it.
Yes.
Just like that. Just like that. So does that make sense to everyone? I'll say it again. You're gonna start at the beginning of the list, and one of them is gonna take 2 steps, so one every round. One of them is gonna take 1 step. The other one's gonna take 2 steps. Take 1 more step. The one takes 2 steps. So the pointer that's taking 2 steps is gonna move exactly twice as fast. When it reaches the end, you know the one moving half as fast is in the middle. That's it. It's like 2 runners, right? You know, you have 10 miles to run. You say one of you's going to run at 10 miles an hour. That's a pretty fast runner. One of you's going to run at 5 miles an hour. You know, after an hour, one has run 10 miles, the other one is halfway. It's at 5 miles. It's like that. So, okay. I'll share my screen and code that up real quick. Okay, where are we? Where am I? Doubly linked list. Okay, this is the folder where doubly linked list is. I open up doubly linked list. This is our doubly linked class, and remember we refactored it during instructor hour the other day to make some of these methods a little bit shorter, but nothing has changed since then. So let me do def find middle element. Oop. Don't do whatever you're doing, editor. And let me see, I need 2 pointers, right? I can do like my 1-step element. We're gonna start off at self.head, and my 2-step element, pointer. I'll do pointer because that's clearer. We start them both off at head. Right? And when 2-step pointer reaches the end, it'll set itself to none. So if it's none, it's not true, not truthy. So while 2-step pointer, if we want to be real clear, we'd say is not none. We'll say 2-step pointer equals 2-step pointer dot next. So we bump it along 1 step. Now, if 2-step pointer is not none, we have to check that, and I'll explain why in a second. Then we're going to bump along our 1-step pointer, equals 1-step pointer dot next, and our 2-step pointer takes its 2nd step. two-step pointer dot next. Takes a second step.
Yeah, I was wondering how you were going to get it to take 2 steps.
Right, right. And
I
then,
wrote it up. I think flip the sheet.
yeah. And the reason I do that, let me see. I'll tell you what, I'm going to open a new file called test middle element.py, and we're going to import, no wait, that's JavaScript. From the linked list, import the linked list. There we are. So we'll do DLL equals the linked list, and then we're going to insert some stuff into it, right? We'll do add to head a 1, and then we're going to add to the tail two, 3, 4, a 5. 5, right? And then we should do middle element equals DLL dot find middle element. And then we will print. So that should be 3. So we'll say 3 equals middle element dot value. So that should say true, right? Because if we found what we think we found, then it should be 3. So now if I'm going to go back to the left, open up a terminal, and run my test file, test middle element. We have, hey, we have true, so it worked. But I want to show you real quick what happened if I didn't do this step here. And actually, the first time I was doing this, I went ahead and I said two-step pointer equals two-step pointer dot next. I just moved it like 2 steps, and I moved this 1 step.
Ah,
The same. We were thinking the same.
there we go.
Yeah.
That's how you can skip 2.
Yeah, but check out what happens if I do that. What if I have, say, actually, I think that will still work for this. If I run that. Let me see. Whoops, it didn't work. I forget if it fails on even or odds. So, what happens is we start them both up here. That's my 1 step. Here's my 2-step pointer. And so first round, okay, 1 step, you're going to come down. You're going to come down here. There's my 1 step. 2 step, you're going to come down here. That's my first round. Let me go back to here and show you. It's my first round through the while loop. Second round through the while loop. Okay, we move this down here, and this one moves. Whoops, this one moves forward 1. If I can take it like that. And then our next loop through the while loop, we try to go .next. But .next is none, and then we're calling none.next. And there's no such thing. So we get an error.
Oh, because we're trying to skip 2 next. And there,
Yep, we're already at 5. So our next round through, loop through the while loop, we say, .next. That first .next, we get a none. And then we try to get .next. None hasn't got a .next, it's just a none. So for that reason, we had better check. Let me go back to the correct. There we are. For that reason, we check. We move 1 step with the 2-stepper, and then we check and see what we've got. I think if you have an even number of elements and you don't check, you won't get an error. But with an even number of elements, remember, we still want that 3. But it would instead give us, I forgot, I think it gives us the 2 or something. It doesn't do the right thing in any case. Okay, we need to move swiftly onward. We're running short of time. So let me think about what time do I have here? I'm trying to think if I should delay any of this. No, I will. Let's charge forward, and we'll just go through the next parts of the class a little quickly. Okay, let's do the second challenge, and then when we come back, we'll go through it, and we'll take a brief break and finish the class. Okay, so second challenge. Oh yeah, second challenge. You guys are gonna love this. Your second challenge is to reverse a singly linked list. And here is, and I will explain to you what I mean by that. And if a recursive solution occurs to you, don't use it. We'll have a non-recursive solution. So reverse, your challenge is, should you decide to accept it, reverse a singly linked list without recursion. So what I mean by that is, suppose I have like a list like this up here. I'm going to copy it down. What we want to do is we want to take all of those pointers and point them the other way. So node 1, well, I guess you can now point at nothing. You're none because you're the tail. That points that way. That points that way. That points that way, that points that way. And that's that. Now it's reversed. So at the beginning, if we had printed out all of the values in order, we would have seen like 1, 2, 3, 4, 5, 6. And now if we print them all out in order, we would see 6, 5, 4, 3, 2, 1. So our head has become our tail, and our tail has become our head. We want to reverse a singly linked list. And remember, it's singly linked, so the same rules apply. Singly linked list, you don't know the length of it at first, it doesn't really matter. And we'll use the doubly linked list class, but no use in previous pointers, so that we're using it as a singly linked list. And reverse it. Make it point the other way. This is actually like a famous coding challenge, despite the fact that it has, as far as I can tell, no real-world application. Any questions before Jonathan pushes us all out into pushes you all out into your groups?
Can we use something else like a stack or a queue? Or...
I'm going to say no. And actually, therefore, this time I will add what I said the first time, constant time, constant space. No.
Help.
What's that?
A stack would help.
A stack would help, yeah, right. But that would take extra space. So no constant time, constant space. No, double passes, no other data structures. Okay? I'm glad you reminded me of that one. All right, I will unleash you.